Okay, in this video I'm going to review the Hardy-Weinberg variables and what they mean. One of the hardest things about Hardy-Weinberg problems is understanding what variable the word problem is telling you and what variable the word problem is asking for. So this is the first step in understanding Hardy-Weinberg problems. Okay, these variables p, q, p squared, q squared, and 2pq are all referring to the frequency or percentage of something. So all of my definitions are going to start off with the words frequency of, and when I work problems, I'm going to work in decimals or percentages. So first of all, what does the term P represent? The term P represents the frequency of, and I'm going to abbreviate, the dominant allele. In other words, what percentage of my alleles are the dominant or capital allele? Q represents the frequency of the recessive allele. In other words, in my population, out of all my alleles, what percentage of the alleles are recessive? If my alleles can either be dominant or recessive, then the variable P plus Q must equal 1. This is telling me that in my population, my alleles are either dominant or recessive, so the frequency of each must total 1 or 100% of my alleles. The next three variables are talking about allele combinations, or the three different genotypes. For example, p squared is referring to the frequency of the homozygous dominant, and I'm abbreviating, genotype. Q squared, on the other hand, is going to refer to the frequency of the homozygous recessive genotype. And then finally, my last category of genotypes is heterozygous. So 2pq, that full term, is going to refer to the frequency of the heterozygous genotype. So my first two variables, P and Q, just refer to allele percentages, what percentage is dominant versus recessive, whereas these three categories refer to allele combinations, or the three different genotypes a population can have. Once again, these last three terms, P squared plus 2pq plus Q squared, must equal 1, because the frequency of each of these three categories will equal 100% of your population. Let's look at some phrases and just decide which variable the phrase is talking about. So for example, if a word problem said, in a population of 500 individuals, the frequency of the recessive allele is 5%. It's not talking about an allele combination, it's strictly telling me what percentage of the alleles is recessive, so that is referring to Q. If I was to write that in a problem, I would say Q equals 0.05. Okay, my next one, in a population of 1,000 individuals, 250 show a recessive trait. Well, the only way to show a recessive trait is if you have the allele combination of being homozygous recessive. For example, little a will show that recessive trait. So here, this phrase is referring to Q squared. In a problem, I would have to start off with Q squared. I would start with a fraction and then write that as a decimal. Okay, let's keep going. Albinism is an autosomal recessive trait, and in the United States it says 0.75% of the population are albinos. This percentage are albinos. The only way to be an albino is if you have the genotype of being homozygous recessive. They tell you it's a recessive trait. So this must be telling me Q squared. In a population of 1,000 individuals, 875 show the dominant phenotype. This is different. Well, hopefully you're thinking in your head, well, there's two different ways to show the dominant phenotype. I can either be homozygous dominant and show the dominant phenotype, or I can be heterozygous. So the information that 875 show the dominant phenotype is actually telling me about p squared plus the term 2pq. So p squared plus 2pq will equal my 875 out of 1,000 individuals. Okay, we'll work problems later that deal with the dominant phenotype in another video. My last three dealing with mice here. Brown fur is going to be dominant over white fur in each of these last three. It says here that out of 50, 35 are white. Well, if brown is dominant over white, the only way to show the white fur was if a mouse is homozygous recessive. Homozygous recessive is represented by q squared. So in a problem, if I was working a problem, I would have to start off and think that q squared is 35 out of 50, and then turn it into a decimal from there. My last two. In the last two, the frequency of the big B allele is 0.5. It's not telling me an allele combination. It's not talking about a genotype. It's strictly telling me that the dominant allele frequency is 0.5. So P is what this phrase is telling me. And in a problem, I would have to write down P equals 0.5. The very last one. Brown fur is once again dominant over white fur. 48% of the population is big B, little b. It is telling me about an allele combination. It's not just talking about one allele. It's talking about the heterozygous genotype. My heterozygous term, use that full term, 2pq, don't leave off the 2. 2pq represents my heterozygous individuals. So in a problem, I could state that 2pq was 0.48. Okay, hope that helps explain the Hardy-Weinberg variables. In future videos, I'll work some Hardy-Weinberg problems.